Hello friends, myself Chandra Kumar. I am taking power electronics as a subject for the third year electrical engineering students. In continuation of the previous lectures on the DC choppers, in the previous lecture we will discuss about the type A choppers, then we will discuss about the type B choppers, then we are discussing about the type C choppers, and their waveforms. Now we will discuss about the type D choppers. Type D or two-quadrant type B chopper. Thus D is a two-quadrant chopper when both CS1 and CS2 are triggered simultaneously. The output voltage V output equal to Vs and output current flows through the load. When CH1 and CH2 are turned off, the load current continues to flow in the same direction through the load D1 and D2 due to the energy stored in the inductor F. Output voltage V output equal to V minus of Vs. Average load voltage is positive if chopper on time is more than the off time. Average output voltage becomes negative if T on is less than T off. Hence the direction of load current is always positive, but load voltage can be positive or negative. So that the T on it must be more than 0.5. Average value of V output and I output are positive. Power flows from source to load. If the T off is more than 0.5, the average value of V output is negative and I output is positive. Power flows from load towards the source. So this will be the circuit diagram. These are the equations which are associated with the V output voltage, and we are finding that the V output voltage finally it will be the Vs into T on minus T off upon total time. So the difference of the output on time and the off time it will be dividing by the T to get the output voltage. So V output is positive for T on is more than T off. V output is negative for T on is less than T off. V output is zero when the T on is equal to the T off. This is the circuit diagram for the type B or type C. Two types, two quadrant type B chopper or type D chopper. In this case, we are finding that the chopper 1, switch 1 and switch 2 is placed over here. Diode 1 and diode 2 is operating over here. And in between there is a load. So this current will be flowing through this one. So whenever we are saying that the CH1 is operating, then automatically the supply is moving towards this side. So it will be flowing, it will completely pass with the help of this one. So it will be in the positive to negative direction. Once the negative part is operating, at that moment we are finding that the direction it will be just the reverse bias, or we can say that the whatever energy will be stored within the load, it will be reverses towards this side, right? So the operation over this side will be the output whenever we are just compare according to the quadrant type, then the output current it may be positive or negative. It may be positive, but the output voltage it may be positive or negative both. So for the first part it will be positive, for the second part it will be negative. And the positive quadrant, first quadrant operation and negative fourth quadrant operation will perform during the type D type of chopper. This will be the output voltage T on. When once the T on is on, then we get the output voltage. It will be based upon the chopper 1 and the chopper 2. So first one, it will indicated for the chopper 1 and chopper 2 it will be on. So we are getting the on time. When the both of them are off, then we are getting the value of the I1, right? So this kind of waveform we are getting over this side, and the supply current it will be moving from the when the TSCH1 and the CS2 both are operating, and it will be in the reverse direction while the D1 and D2 are operating. So means if both switches are off and the diode will be discharged and the load will be discharged through the diode 1 and diode 2, right? So this is the operation for the diode 1 and diode 2 over here, and we are getting the negative sign of waveform. So this is the waveform for the current. Then what is the status of the current? Current will be increases due to the operation of the inductance. If the load is inductive type, then Forward motoring operation. It is the first quadrant operation when switches T1 and T2 are conducting both the output current and output voltage are positive. Now the circuit path will be Vs T1 load T2 and Vs. So the power is flows from the source to load. This is known as the rectifying operation. This operation occurs in first quadrant as the current and voltage are positive. So or the operation of the T1 and T2 are conducting and the supply with load, it will be operating like this. Next mode is the inverting operation, a reverse braking mode operation. It is the fourth quadrant operation. When switches T1 and T2 are switched off, the load inductance generates a huge amount of voltage to maintain the current in the same direction. The inductance voltage forward biases both D1 and D2. Now the circuit path will be load or D1, then Vs, then D2, then load. Here the output current is positive, but the output voltage is negative. That is the power flows from load to source. Thus we can achieve reverse braking operation. Here the motor speed can be controlled by changing the duty cycle of the machine. So diode 1 and diode 2 are operating and the both switches are under the off stage, and the whatever energy stored within the inductance and the load, it will be delivered from this side towards the source side. Next will be the type E chopper or the four quadrant opera chopper. It consists of four switches and four diodes in anti-parallel. Numbering of chopper is done corresponding to a quadrant operation when CS1 and CS4 are triggered. Output current I output flows in positive direction through CS1 and CS4, and with output voltage V output equal to Vs. This gives the first quadrant operation. When both CS1 and CS4 are off, the energy stored in the inductor will rise all output through D2 and D3 in the same direction, but output voltage V output equal to minus V. Therefore, the chopper operates the fourth quadrant operation. When CS2 and CS3 are triggered, the load current I output flows in opposite direction and output voltage V output equal to minus V. Since both I output and V output are negative, the chopper operates in the third quadrant. When both CS2 and CS3 are off, the load current I output continues to flow in the same direction D1 and D4, and the output voltage V output equal to V. Therefore, the chopper operates in second quadrant as V output is positive but I output is negative. So this will be the circuit diagram and the operation. Over here we are finding that the every chopper there is a antiparallel, there is a connection of the diode. So CS1 with D1, CS2 with D2, CS3 with D3, CS4 with D4. And for the reverse bias, it will be the just opposite, and the battery and the operation is like this. So this will be the four quadrant operation. Four quadrant operation. The process will be explained in the previous slide, and we are finding that the how many diodes, how many switches are operating at this moment. So whenever we are saying that there are two choppers on step down, so CH1 operated, CS1 and CS2 is on, CS1 is off, CS4 and D2 are conducting. Then for the second quadrant, one chopper on step up. In third quadrant, two choppers on step down. In the fourth quadrant, one chopper on step up. So this will be the practical operation of the type E types of choppers. This will be the equations which are operating for the first quadrant. Chopper 2 and 3 are off, chopper 1 is on, chopper 4 is on, CH1 is operated, CH1 and CH4 being on. V output equal to Vs, I output current starts flowing. Both V output and I output are positive with CH1 is off, positive current free wheels through CH4 and D2. Both V output and I output are controlled in the first quadrant, acts as step down chopper. Similarly, there is operation of the second quadrant, third quadrant operation, and the fourth quadrant operation. Thank you. Thank you for attending the lectures. Thank you for